As young economists, you are going to come across sigma notation. It's a compact way of writing a series of operations, often involving, you guessed it, sums. So for example, we might have something like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. And you could do that. Looks a little bit cumbersome. It's an awkward way to write something. If you're writing this in a research paper, you're going to take up the whole line. And if we want to do something more involved, we might get this sort of dot, dot, dot here that tells you the sequence is continuing. And you'll see both of these. Now, how can we use sigma notation to make this simpler? And when I say simple, I mean compact. So I can write a sigma. This is the Greek capital letter sigma. Now I'm going to pick my starting point, and my starting value is 1. So this is going to be where I'm starting, and I'll name the index I. I for index, that's a popular name. And the index I starts at the value 1. And I'll add an I there. And we're going to add all the whole numbers starting at 1 until we get to the number 8, right? And this is the end value, and so I'm going to write an 8 here. That represents the end of the series. And that's how we write 1 plus 2 da 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 up to plus 8 as in sigma notation. Looking at the bottom example, I'm going to start by drawing the sigma sign. I want to know where this series is going to begin. Well, it begins at 1. So maybe I'll call this series n to be a little bit different, also a common name for a series. So we're going to start at 1. I've called it n here, so I'm going to put my n right there. That's where we're going to sub in the values for n. This is my series. And where do we end? Well, we're going to sum all the way up to 101. And so I'm going to put 101 for my end point, and I've got 1 for my starting point. Here is a summary slide of summation symbols. Here we're using n as the name of the index. And you can see it appears both at the bottom of the sigma sign, and it has to appear somewhere to the right of the sigma sign because we're going to operate on it. We've got n is equal to something. I need a starting point, and capital N is our end point. So for example, let's let the start n equals 1 and the end, capital N, is equal to 6. And so what will we do with this general form? I'm going to add my start point right there. I could do a couple of things. Well, I know that capital N is equal to 6, so maybe I would just scratch it out and put the 6 directly up there. I could do that, or I could just leave the capital N. You usually do not see something like capital N equals 6. That's not usual. And now I'm going to complete the summation operation. So I've got 1, my initial value. Then after 1, I plug a 2 into the end. Then n is equal to 3. I'm just counting up the whole numbers. N is equal to 4 plus 4 plus 5 plus 6. And that's going to be equal to, what, 21. Now things can get more advanced. We're going to start making this more and more complicated. Why are we making it more complicated? Not to punish you, but to give you an example of the way that you're going to use sigma notation in your career as a young economist. And so we're going to have something like this. Sigma, maybe I want to start from 3, and I'm going to go up to 5, and this time I'm going to have 2i. And so what does this look like when we expand the sigma notation? We're going to start with 3, so we've got 2, 3, plus 2, well, what's the next number? 4, plus, what's the next whole number? 2, 5. And so this is going to be equal to 24. Before we go any further, this is a good time for a check-in question. Press pause on your video, answer the question, then continue. Now the actual answer is E. It can be both A or C. If we call the series M, then we're going to get 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11. We just count from 5 to 11 using the whole numbers. Similarly, down here, if we call the series I, we get 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11. What about this one? Well, this is illegal. The start point is bigger than the end point. Right, so B is not a great answer. What about this one? Well, this is illegal as well. There's no index to the right of sigma.